Now we can move on to the emulator creation. We'll need it later. To do this, we choose the Tools Manage AVDs option from the Android SDK Manager. We can see that the Android Virtual Device Manager tool opens. It's used to manage the emulators prepared to be launched. We click the Create button and choose the emulator name. We can specify the characteristics of the emulated device. We can emulate one of the particular Google Nexus devices or choose one of the available standard characteristics. For the sake of the example, let's choose Nexus 4. The target specifies the API version which we want to have installed on our emulator. If we choose Android 4.4W version, we would get a device which is a clock. That is why we had to install the API version 19, which we'll choose now. Here, we also have the possibility of choosing the CPU type. I only have the x86 CPU. In the previous Android versions, the ARM emulator is the default emulator, but it is much slower. In the latter part, we can choose the hardware buttons which will be available. We can also choose the skin, that is, the package for our emulator window. We can also specify whether the camera is from the front or from the back. We can choose one of the cameras connected to the system or choose the emulated option. And then Android will simulate a camera by displaying a moving rectangle which we can photograph. In the next part, we can find the memory constraints for the entire device. Obviously, large resolution devices need more memory. However, we should watch out because the Windows system has an error which prevents the emulator from starting once we've chosen RAM memory over 768 megabytes. In our case, let's assume that we have 1024 megabyte RAM. The important thing is that the amount of the allocated memory will indeed be used by the emulator. Another issue is the stack size. This is the amount of memory available for a single process instance. This amount depends mainly on the display resolution. The higher the resolution, the more memory is needed. We can also mount an additional memory card, which will be emulated as a file. Another thing, which is absolutely crucial, is the Use Host GPU option. After selecting this option, all three-dimensional elements will be drawn using the 3D acceleration available in our computer. This makes the drawing process significantly quicker and enhances the quality of the available graphics. Another option is Snapshot. This option causes the state of the emulator to be saved the moment the emulator is closed. Thanks to this, the emulator starts much faster at the next launch, because we don't have to wait for the entire loading procedure to be performed. However, the snapshot option is not available with the Use Host GPU option. After clicking the OK button, the Android emulator is ready. Let's launch the emulator. We'll need it in a moment. Once the emulator has been created, we can also launch it from the Android Studio level. Actually, it's the most common way of launching the emulator. Once we've launched it, we see that actually it's a normal Android system where we can start applications in a standard way. The only difference is that emulators don't have Google Play. We cannot install store applications on such a system. We can only install the applications which we have on the computer. Additionally, the default emulator version has no Google services. Because of this, we can't use maps or services such as payments in our applications. If we want to use such services, we need to choose another emulator. When using the SDK Manager, we need to install a special emulator in the Google API's version. It's a kind of emulator which allows using maps, payments, and other functions made available by Google. It's a somewhat heavier and slower emulator, so if you don't use any additional functions, your best bet is the basic version.